Kristian Cuevas, and in this video lesson we are going to discuss finding interest rate and time in compound interest. Our objective in this lesson is to solve problems involving interest rate and time in compound interest. In finding the number of periods denoted by letter N for compound interest, we will use the formula F is equal to P times 1 plus J raised to N. In order to find N, we will divide both sides with P, and the answer will be F over P is equal to 1 plus J raised to N. In order to isolate N, we will express our answer in logarithms, which is log F over P is equal to N times log 1 plus J. After that, we will divide both sides with log 1 plus J. Thus, N is equal to log F over P divided by log 1 plus J. For finding the interest rate denoted by letter J per conversion period, we are going to use the formula F is equal to P times 1 plus J raised to N. First, we are going to divide both sides with P, and the answer will be F over P is equal to 1 plus J raised to N. In order to cancel out N, we are going to apply the nth root to both sides. Thus, the answer will be the nth root of F over P is equal to 1 plus J. Thus, J is equal to the nth root of F over P minus 1. Now that we know both of our formulas, I will hand over the video to Gia Madera and Mark Anthony Segovia, who will be giving us our sample problems.
How long will it take 1,000 pesos to earn 300 pesos if the interest is 12% compounded semi-annually? So our given is P is 1,000, F is 1,300, and our I squared equals 12% or 0.12. Our M is 2. Our interest rate is I squared over 2 equals 0.12 over 2 or 6. And we have to find our number of periods and our time here. Here is an example where we use the formula for finding the number of periods, which is denoted as N. So what we will do here is we will find the number of periods and the time. Okay, so since I've already substituted the given to the formula, and I have used the calculator already, the value of N is 4.503 periods, which is then rounded up to 5. So now to find time, which is denoted as T, we can use the formula T equals N over M by substituting T 5 over 2, which is equals to 2.5 years. So that's how you find the number of periods N and time.
Hey, this is Mark, and I am going to be giving you two examples in finding J and also the nominal rate. So this is our first example. We have a problem here. At what nominal rate compounded semi-annually will 10,000 pesos accumulate to 15,000 pesos in 10 years? So what we're going to do here is we're going to use the formula in finding the future value, which is F is equals to P times the quantity of 1 plus J raised to N. We're going to use this formula to find J. And from the given problem, we're going to substitute the values in this formula. Our future value is 15,000. 15,000, so we're going to substitute it here. 15,000 is equals to the present value, which is 10,000. 10,000 times the quantity of 1 plus J raised to N, which is 2 semi-annually is equivalent to 2 times 10 years, which is equals to 20. So 20. And then the next thing we're gonna do is we need to transfer this 10,000 to the other side so that the goal here is to isolate J, this one. So in order to do that, we're going to divide both sides by 10,000. Then cancel it. What's left is, oh no, and then what's left is 1.5, which is a value, which is the quotient of these two values. 1.5 is equals to the quantity of 1 plus j raised to 20. And then we are going to eliminate this 20 here, this one, by raising both sides to 1 over 20. So this 20 will be cancelled. And then what's left is 1.5 raised to 1 over 20 is equal to 1 plus j. And then we need to transfer this 1 to the other side so that what's left is j. So in order to do that, we're going to apply the addition property of equality. So 1, the quantity of 1.5 raised to 1 over 20 minus 1 is equal to j, 1 plus j minus 1. So what's left here is j equal to 1.5, the quantity of 1.5 raised to 1 over 20 minus 1. Then we simplify it. So the answer is j equal to 0.0205, or equivalent to 2.05%. So that's our j. So after finding the value of j, we need to substitute it to this formula to find the value of the nominal rate, which is denoted by I raised to m. So j, which is equal to 0.0205, 0.0205 is equal to I raised to m over m, which is equivalent to 2 because it says here that it is semi-annually, compounded semi-annually. So our value for m is 2. And then we need to eliminate 2 by multiplying both sides by 2. So this 2 here will be cancelled, and what's left is 2 times 0.0205 is equal to I raised to m. And then we simplify it, and then the answer is I raised to m equal to 0. Oh, sorry. Uh, I raised to m equal to 0.0410, or equivalent to 4.10%. So this is our answer for example 1. So moving on to our second example, at what interest rate compounded quarterly will money double itself in 10 years? So what is asked here is the same with the previous problem. It is the interest rate or the nominal rate. With the same process, we use this formula, the formula in finding the future value to find J. So our future value is, it says here that at what interest rate compounded quarterly will money double itself in 10 years? So we can put here 2p equal to present value times the quantity of 1 plus j raised to the value of n, which is equal to, I mean, which is equal to 40, because it says here that compounded quarterly, so it is equivalent to 4 times the times 10 years, so 4 times 10 is equal to 40, 40 here. So why 2p? Because it says here that the money will be doubled in 10 years. So the present value will be doubled in 10 years. So um we can represent it by 2p. And then moving on, the same process, we need to eliminate p. So we divide both sides by p. This will be cancelled, and this too. What's left is 2 equal to the quantity of 1 plus j raised to 40. And then raise both sides by 1 over 40 to eliminate 40 in this side. To eliminate this one. Excuse me. So 2 raised to 1 over 40 is equal to 1 plus j. Then transfer 1 to the other side. 2 raised to 1 over 40 is minus 1, sorry, is equal to j, yeah. And then we simplify it. The answer will be j is equal to j is equal to 0.0175, or equivalent to 1.75%. So that is our j. After that, we need to substitute it to this formula to find the value of the interest rate or the nominal rate, which is denoted by 1 to 1 raised to m. So j, which is equal to 0.0175, 0.0175 is equal to I raised to m, which is equal to 4 since it is compounded quarterly. So I raised to 4 over the m is just like what I've said, 4. And then the next thing we're going to do is multiply both sides by 4 to eliminate this one. So this will be cancelled. And then what's left is 4 times 0.0175 equal to 1 raised to 4. I raised to 4. Then simplify it. So the answer will be I raised to 4. I raised to 4. So the answer will be I raised to 4 is equal to 0, 0.070, or equivalent to 7%. So this is the interest rate. This is our answer for the second example. Yeah, that's it.
So there is still one last part of the lesson. So there is the equivalent rates, the nominal rate, and the effective rate. So let's start with the definitions of these concepts. So first, equivalent rates. This is the two annual rates with different conversion periods that will earn the same maturity for the same time or term. And then the nominal rate, which is denoted as I to the power of m, is the annual interest rate, which may be compounded more than once. And then the, of course, effective rate,
denoted as I to the power of 1. Rate when compounded annually will give the same compound each year with the nominal rate. So there is one problem here that we will try to solve using the concepts of effective rates, the nominal rate, and the equivalent rates. So the problem here is, what effective rate is equivalent to 10% compounded quarterly? So the givens here are the nominal rate, which is I to the power 4, is equals to 10% or 0.10. And the conversion period, which is denoted as M, is equals to 4. So the goal here is to find the effective rate, which is denoted as I to the power of 1. So here's the solution for that problem. Let f sub 1 be the future value of the effective rate, and let f sub 2 be the future value of the nominal rate. So by using the concept of equivalent rates, we can say that f sub 1 is equals to f sub 2. And then by using the future value formula, f is equals to p times the quantity of 1 plus the nominal rate or the effective rate over the conversion period, which is then raised to the power of the conversion period times time or term. So by using this formula, we can then substitute the effective rate and the nominal rate. So on the left side is the effective rate. So P times the quantity of 1 plus the effective rate, which is I to the power of 1 over 1, and then raised to the power of t, because 1 times t is just t, and then equals to the future value of the nominal rate, which is p times the quantity of 1 plus the nominal rate all over 4, and then raised to the power of 4t. So the goal here is to find the effective rate, letting the effective rate be the only one on the left side, and also getting the value of that effective rate. So let's start. First, let's divide both sides by p. So divide by p, divide by p. We can cross them out, which is then equals to 1. And also, we can also cross out the t, which is the time, by raising the power to 1 over t. So let's 1 over t. We can then cross them out. Now, what's left is 1 plus the effective rate equals to 1 plus the nominal rate, which is, if you remember, is 0.10 over 4, and then raised to the power of 4. Now, since there is a 1 here, we can then transpose it to the other side. So I to the power of 1, the effective rate rather. So 1 plus 0.10 over 4 raised to the power of 4, and then minus 1. This will gives you, if we calculate it, it becomes 0.103813 or 10.3813%. So that's how you solve the problem about effective rates, nominal rates, and the equivalent rates. So that is the effective rate equivalent to 10% compounded quarterly. That's all.